And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, and we're looking at a close-up of a solar flare and coronal mass ejection producing event that occurred last night, right about 1900 hours Universal Time, 7 p.m. Greenwich Mean Time, was the moment of peak flux. Great view here from the Solar Dynamics Observatory. Here's a full disk view in the same wavelength, and now we're looking at a full 24 hours of stellar activity here from the closest star. And we don't expect any of these coronal mass ejections to be Earth-directed. Just a quality light show. Possibility for additional solar flares and indeed coronal mass ejections still there, folks. And we actually saw a solar flare kicking off as we did the show today. So we're actually recording at a moment when a solar flare is happening. So here's the viewpoint from stereo A. This is located at Lagrangian point 5. And you can see this coronal mass ejection is somewhat directed toward stereo A, as you can see a halo around the coronagraph obscuring disk, this black area in the middle. But indeed, most of that coronal mass ejection will miss even stereo A to the east, and you can see most of the ejecta on the left side of the coronagraph. We may see a small spike on stereo A. We're not expecting to see any damage or anything like that. It's pretty much directed to the east of stereo A. So here's the LASCO coronagraph, located at Lagrangian point 1, right between the Earth and Sun. It looks like we've got some missing data there, but there's where that coronal mass ejection occurs, and you can see all of the ejecta is on the left side of the coronagraph here. And here's the LASCO C3, also located at that same spot. Lagrangian point 1, the gravitational equilibrium point between Earth and Sun, about 1 million miles toward the Sun. And there you can see this propagating entirely off the east side of the coronagraph. I'm not sure why the Integrated Space Weather Analysis Center is showing a glancing blow possible on Earth. This is nowhere near Earth. Again, most of it will even miss stereo A. Here's another full disk image. We're now looking at 304 angstroms ionized helium, and this is a full day. And there's that solar flare kicking off. That was an M-class solar flare, folks. The largest we've seen in quite some time. And sunspot 2822 is a beta-class sunspot. So again, likelihood of additional significant solar flares still there. Here's 193 angstroms, which actually shows you the best imagery of this shock wave. You're going to see a shock wave over this whole area. Check it out. Right here, you can see effects on the entire eastern portion of the Earth-facing disk. Fantastic imagery there in 193 angstroms from the SDO. And we've got more close-ups here. It's a legit space weather day. Fantastic imagery there in ionized iron, one of the many ionized states of iron, 193 angstroms. A great wavelength for seeing coronal holes. Here's ionized carbon. And you're going to see a very bright indication that there's a lot of carbon suddenly appearing. And it is likely to have been produced during that solar flare. That brightening there is an increase in the amount of ionized carbon. It's 1600 angstroms. Fantastic imagery there. We've got a whole bunch more data to blast through. First, the magnetogram. And what we've got here are two North Pole-oriented umbrae. That's North Pole, and this is North Pole. And this umbra down here is a South Pole-oriented umbra. And we'll be keeping an eye on Sunspot 2822. And when I say eye on, well, the pun is intentional. Here's a chart of the solar system. Little visualization. Keep in mind, this is not to scale. As we approach a new moon, there's where things will be in 1 week on May 15th. Here's a star chart. And we've got Jupiter, Saturn, and the moon having just risen at my location, which is Lehigh Valley, Pennsylvania. The radial flux has come up to 75, and we're expecting to see this come up even higher than this with that large beta-class sunspot group. Here's the 1-year chart of the radial flux. It's this black line. To put it in context, red line beneath it is the proportional data set of sunspot number. We're not expecting any solar storms or anything like that. Again, coronal mass ejections are expected to miss the Earth, at least as far as current data is showing us. And next we're going to do earthquakes and volcanoes. And I just wanted to cite the quality of the data here at volcanodiscovery.com. So you can see these bar graphs. There's 2018 global seismic activity in bar graph form. There's 2019. There's 2020. Here's the year to date. And here's the 90-day graph of seismic activity. You can see we're seeing a lull in 7 and 8 magnitude quakes here. Love the volcanodiscovery.com's earthquake information. You can also sort it by magnitude. And we did see a 6 magnitude in the past 24 hours. We'll get to it. Series of 4 magnitude quakes here north of India here in Central Asia. And the largest was this 6.0 located right near the Austro-Antarctican plate boundary. Let's go up the list from USGS. So a couple deep quakes here, including one at Indonesia and one at the Solomon Islands. Those are both in a 4 magnitude range. A couple of 5 magnitude quakes there, including this one in the North Atlantic Ocean. East of the Caribbean. Also Chile saw a deep quake near the Chile-Bolivian border region there at a 4.6. And there's that 6.0 south of Tasmania. Quite far south of Tasmania. Quite a few deep quakes here, including another one in South America, a small one in Alaska. A deep quake near Fiji at a 6.1. Okay, that's actually the largest of the past 24, folks. A 6.1 near Fiji at over 380 kilometers estimated depth. Also a deep quake in the Kuril Islands. And also another deep quake in western South America. Another deep quake near Chile, or near Mexico. That's actually nearly 100 kilometers depth. Also another deep quake in the Bandai Sea. So lots of deep quakes kicking off in the past 24. Let's see what volcanoes have been erupting. Subanosejima. Has been observed producing volcanic ash. Sinabung exploding. 12,000-foot ash plume above it. Semeru in Indonesia. 14,000-foot ash plume there. Dakono exploding. Flight level 090. It's a 9,000-foot plume of volcanic ash. Popocatépetl has dissipated its ash, although Sangay in Ecuador is exploding. Flight level 240, it's a 24,000-foot ash plume. Revenador also exploding, 15,000-foot ash plume, and we're unable to detect Sabancaya. Don't let that be an excuse to attempt to pole vault the caldera. Please don't do so. We need the views, and if you'd like some merch featuring this fantastic design here, a public service message from smAsho.com. Head to smAsho.com, click on smAsho merch. You'll find seven designs, divine designs, in our Redbubble shop. And one of them is the Do Not Pole Vault the Caldera series of products. There are 50 products featuring this relatively new design. And check out the other ones as well. We've got some tote bags for some mothers for tomorrow on Mother's Day. And back to the sun-facing suite of instruments on the Go 16. And there you can see that M-class flare. Again, peak flux was at, I think it was 1904 Universal Time, right around 1900 hours Universal Time, 7 p.m. 7 p.m. Zulu. Next, the Go's Proton Flux, no strikes in that, and no surprises there. We're not expecting any, as we still don't see any Earth-directed coronal mass ejections. Here's the Go's magnetometer over the past 3 days. Earth is solidly in a south pole current sheet. We are expecting it to remain there for the foreseeable future. Here's some data on that. The Gong 2 data, the top view ecliptic plane field plot. Keep in mind the data is 1 hour and 24 minutes old from when we made the video. South pole current sheet shown here in red. North pole heliospheric current sheet polarity shown in green. Here's a line of sight view of the same data, a three-dimensional representation of the polarity of the current sheet. It also shows you that blue line there. That is the sun's B field line. That's how far up you'd have to be in the other current sheet, essentially. Why did the proton cross the solar system, folks? To get to the other current sheet. So here's the line of sight coronal hole plot, and you can see this significant south pole oriented coronal hole here starting to stretch up toward the equator. And you can see the sun's B field shown here in blue making its way down to the south here on the western limb of the sun as cycle 25 continues to progress very slowly. So here's detected filaments and detected sunspot groups, and you can see sunspot 2822, the beta class sunspot. It's got 3 main umbrae. 2 are north pole oriented, 1 is south pole oriented. And there's a bit of anomalies here on the filaments detection. There really is not a filament stretching all the way around the sun like this. That's just not there. I don't know what the anomaly is. There is still a filament down here in the southwest, which part of it erupted and collapsed yesterday. Continuing on with global geomagnetism, the KP index is currently at 0, having only been at 1 or 0 over the past 24 hours. And how about the real-time solar wind? At the Smash News Network, least busted name in news. We're interested in all the relevant data points. Solar wind density just below 5 protons per cubic centimeter. Solar wind speed still at quite low levels here, not quite as low as yesterday, 326 kilometers per second. Here's 4 hours of geospace magnetosphere movie. We're looking at magnetohydrodynamic pressure measured in nanopascals. And we're seeing a fairly steady wind and a fairly steady geomagnetism out to about a dozen Earth diameters as shown in this geospace magnetosphere movie. Small increase in the pressure there at the end. Next, we'll show you ground magnetic perturbations. Changes to the Earth's B field known as geospace delta B. It's also 4 hours of data. We try to show it daily when it's available, as the data is not accessible in an archived format. Shout out to University of Michigan. Perhaps you'd like us to be able to view the older data. Maybe set up an archive on the site so we can feature more of this in future videos. Anyway, that's 4 hours of data as well. Geospace delta B. Keep in mind the measurement is in nanotesla here as opposed to nanopascal. Now, we regularly do stream live to Twitch. Today we're not doing a live Twitch stream thanks to our Twitch viewers. Check out the mobile app. It's very good, as well as the live streaming platform twitch.tv/smAshomash. We're also on BitChute. Look for more exclusive content coming there sometime soon. BitChute.com/smAsho. Thanks to our new subscribers over there. And also on YouTube. Most of our content is on YouTube. Check our playlists, youtube.com/smAsho/playlists. If you're only watching someplace besides YouTube, you're missing probably like 70% of the content. And today's cosmology segment will be integrated into the daily space weather video. We're going to blast through some more information here. Today's random number generated was 492, which coincides with an object over at the Neil Gorell Swift-Bat X-ray Observatory. This one is Quasar B1440 plus 122. Here it is on the Pan-STARRS optical telescope, very high-resolution imagery there. And I believe this is actually a foreground or more likely a background object, a galaxy. And it's a quasar. It's a BL Lacertae object, meaning it is a full-spectrum quasar. It is the brightest in... It's bright in the entire frequency range, the entire electromagnetic spectrum. And there it is in X-ray, as reported by the Chandra. Does it show up on the Multi-Mirror project? It does not. Does it show up in blue light? And there it is in blue light as well. Quasar B1440 plus 122, today's random object for today's cosmology segment. There are the X-ray transients from it. We've only got limited data on this. It must be a relatively new discovery, and it looks pretty faint. It's probably at a great distance. Did you watch our video from last night, the SDO multi-wavelength footage M-class solar flare video? If you didn't, perhaps check that out. You'll find it right on the YouTube homepage, youtube.com/smAsho. We've made it the featured video. So check that out. Multi-wavelength imagery of last night's M-class flare. Let's go over cosmic rays. We haven't done it for a few days. Here is the Apatity neutron monitor. And you can see pretty flat here over the past 30 days at Apatity, Barentsburg. Also flat over the past 30 days. Let's go farther south to a place called Athens, Greece. There's what's going on at the Athens neutron monitor. Pretty flat over 30 days there. Maybe a tiny downtick. What about Mexico City? Even farther south we see a flat 30-day chart. And how about Oulu, Finland, and 2 monitors in Antarctica? So there's the Oulu neutron monitor, flat over 30 days. DOMC Antarctica. A small uptick over the past 30 days at DOMC. I would also note much lower levels than in 2017, 2018, and even the beginning of 2019. In fact, all of 2019. Here's DOMB Antarctica. Much lower levels than 2017, 18, and 19. But a small uptick over the past 30 days at DOMB Antarctica. That's our cosmic ray section, and here's our astronomy picture of the day. This is deep space at Yakarati. Imagery of the Milky Way there on a clear sky area with no light pollution. And it looks like there's some zodiacal dust showing up there. The dust lane of the Earth. Oh, the unusual yellow-hued reflection nebula above is created by dust scattering starlight around red giant star Antares. That must be Antares right there, the red giant star. It's the astronomy photo of the day, and that's today's cosmology segment. We've left it integrated into today's daily space weather. If you haven't checked out our cosmology segment videos, check out youtube.com/smAsho/playlists. There are pushing 200 cosmology segments in there, and let's continue on to talk about the electron flux. Here's a diagram of the Earth Van Allen belts. Distances are shown here in miles. Here's a 1-year chart of the greater than 2 mega electron volt electron fluence. Here's a 3-day chart of it, and we're in moderate levels here, but we see very chaotic electron bands. We don't see any charging hazards, as levels are moderate. However, organization of the electrons are quite chaotic. We'll get to it. Here's the forecast expecting a little downtick here. There is a small coronal hole wind stream on the way also, and we may see a downtick from that. So here are the chaotic electron densities that we're talking about. We're seeing high densities at nighttime here. So right in this portion, you can see pretty high density levels there. Normally we see clearer. Normally we see less electrons overhead at nighttime, even around the equator. Most GPS errors occur around the equator at noon, not around the equator at midnight, but we see some significant errors occurring around the equator at midnight. I'll let it play through a second time. We've seen anomalous total electron contents for the last about 4 days. And this is showing the entire air column from your handset all the way to your GPS satellite. Next, looking at the ionosphere, it's one slice of the atmosphere, just this F layer right here at about 300 kilometers. This data is courtesy Bureau of Meteorology of the Australian government. Ionosphere also looking a little anomalous here. Although northern hemisphere predictably a little higher vibrational frequency than the south, as we are approaching northern hemisphere summer. Some very significant discharge events there, and some sudden charge ups in the southern Indian Ocean, as you saw there. So some rapid vibrate ups and vibrate downs happening. And megahertz is millions of vibrations per second. Let's bring up the latest image. That's 9 o'clock universal time. For the F ionosphere layer at about 300 kilometers of altitude. Next, here's our meteorology segment, also integrated in today's daily space weather video. Here are the surface winds of the western world. And let's rotate the planet to check out the surface winds of the eastern world. And then we'll go to the jet stream. Here's the 250 hectopascal winds, which elicit the location of the jet streams. There they are in the east. And here are the western world's jet streams. Continuing on with meteorology subjects. Are you interested in where lightning is striking? Well, it gives us great insight into the most intense storms. And we just saw some lightning striking here in southern Missouri. Hey, Springfield. There's thunder rolling in. Next time you hear thunder, check out lightningmaps.org. It could save your you-know-what. As we don't want you to be struck by lightning, it'll likely kill you if you get struck by lightning. And we need the views and subscribers on YouTube. Maybe one of these years we'll reach 2,000 subscribers, folks, and then we'll act like it's a celebratory moment. And here's your NASA GOES lightning mapper. You can see a long string of lightning here stretching all the way. It looks like stretching from Montana all the way down into, and indeed it is. You see that string happening there from Montana down into Kansas. And those systems are largely moving due east. Here's some more information on that. But first, thanks to our patrons, the true source of funding for the content. Thanks, patrons. These videos may not exist and would most certainly not be publicly visible if it wasn't for you. Patreon.com/smAsho. Patrons get all kinds of information that nobody else gets. And you may want to subscribe to our Patreon, because some of our posts are not even payment requiring. In other words, some of our posts on patreon.com/smAsho are publicly visible, even if you are unwilling to open your cobweb-encrusted wallet and send us a measly $3 per month to get the first information on this sort of stuff. Patreon, the true source of funding for the Smash News Network. Least busted name in news. Next, we're looking at snow depth. on windy.com. And look at how much snow is still in the western portion of the U.S. Eastern California, lots of snow there yet, as the spring melt is far from occurring yet. There's still quite a bit of snow in the Rockies and the Sierra Nevadas and also in Utah. Apparently it's so hot that it's cold, folks. The planet is so hot that it's cold. Oh my God, it's so hot that it's cold, folks. Jeez, oh whiz. And by the way, there's more snow in the forecast. Here's the snow forecast through Wednesday, May 12th. And it includes an additional 16 inches of snow here in eastern Colorado, pushing 2 feet of snow there in central Colorado. So yeah, we're supposed to believe that carbon dioxide is making the planet hot as snow continues to fall into May. Here's the precipitation forecast. It's the total accumulated precipitation, and expecting some very heavy rains there in Mississippi. Looks like about 7 inches of rain forecasted for that central portion right there. Again, that is also through Wednesday, May 12th. It's a GFS forecast, as was the snow. Speaking of snow, the planet's so hot that it's cold, folks. By the way, global glaciations happen as a result of the albedo effect increasing because of snowfall. When you get a summer without a year without a summer, that's typically because snow doesn't melt in certain portions, which makes the planet more reflective, which reflects heat and light back into space, which makes the planet colder, and there is a tipping point where the planet can reach a snowball Earth scenario, which will destroy entire civilizations if it happens. We're certainly hoping it doesn't. So anyway, here's the snow water equivalent, which you can see is well outside of the 1 standard deviation range. Here's the snow extent, which is exactly 1 standard deviation above the average. Fortunately, snow mass balance is right on the average here, so we're not expecting that bad of a melt. And there you can see the snow extent. The green line is 2019 to 2020. The red line is 2020 to 2021. And also we've got the South America snow tracker there. Here's the Australia snow tracker. And I would also note once again Antarctica. So here's the graph for Antarctica surface temperature. And I would note that it is 7 degrees Celsius below the 30-year average. 7 degrees Celsius below the 30-year average. And the mainstream media would have us believe that Antarctica is going to melt and cause sea level rise. What a joke. Next, the U.S. Doppler radar map. And it's raining where I am. And again, if you're wondering where we're located, smAsho staff and I are located right about there in Lehigh Valley, Pennsylvania. Snow continues to fall in western Montana, western Wyoming, and northern Idaho, as well as some snow falling in Washington and Oregon there. Even some snow falling in the mountains of West Virginia. Heavy band of storms moving from Kansas into Missouri. It's going to sweep right across mainly the central part of the state there. Here's what's going on in the cloud layer. It's too dark to see it with the visible satellite. We use the 3.9 nanometers radiation map on the NASA GOES Interactive Weather Satellite Suite. Here's the water vapor map. Should give you some additional insight there, and we'll actually zoom in on the border region between Oklahoma and Missouri to show you a close-up for your daily weather pornography section. It should give you some additional insight into how these systems will move. So there's the cloud layer, and you can see some rapid cloud nucleation happening there in eastern Kansas. Hopefully nobody being carried off to Oz in Missouri right now. Anyway, there's that data. Here's one more look at the U.S. Doppler radar map before we close out the meteorology segment. And feel free to check out our other meteorology segments at youtube.com/smashamash/playlists. youtube.com/smashamash/playlists. Here come our bonus features. First one coming from Udaipur, India. It's the hydrogen alpha imagery, and you can see sunspot 2822 up here. Some filaments in the northwest, as well as the southeast and the southwest. So there are quite a few filaments, folks. Again, solar flares have been kicking off. Likelihood of additional solar flares still there with that large sunspot beta class group. And coronal mass ejections could still be occurring also. We'll stay on top of it. Here comes some additional bonus features. It's the colorized magnetogram, as well as the intensitygram. Let's refresh that. So here's the latest data on the intensitygram. And the leading umbra here has actually degraded. So this North Pole umbra has degraded here. This South Pole umbra has remained intact. And that is a significant umbra as well. This is North Pole. This is North Pole. And this is South Pole. And there's the magnetogram imagery to back up what I just said. So 2 North Pole umbrae and 1 South Pole umbra. Here are some more close-ups. Give that a minute to initialize. There's 304 angstroms, just the flare. Fantastic imagery of that. And we've got still more. Here's a composite featuring the 2 wavelengths, 131 and 94 angstroms, which take 10 images per minute instead of only 2 images per minute. So the 131 and the 94 angstroms, 2 ionized states of iron, and the UV emission spectra thereof, we've blended them together for this aqua greenish imagery of the M-class solar flare and coronal mass ejection generating event. Thanks for tuning in, folks. We are out. Remember to stare at the sun, and may that solar wind be at your back.